I know a lot of us have been out recently, so I'm going to work these two examples in video format so you can be ready for your quiz Thursday the 19th. So we're going to work example 1. So the things we need to know for this are y equals mx plus b. This is slope-intercept form, where m is the slope and we find that using y2 minus y1 over x2 minus x1, and b is the y-intercept. B is the y-intercept, and from the coordinates we know the y-intercept is 0, comma, a number, and whatever this number is the b. So the first thing we always do when we get a graph is read it. I don't care what the question says yet. We're going to look at the graph. So asteroid 2012 DA14. The x-axis is distance in miles. Sorry, the y-axis is distance in miles. The x-axis is time in seconds. So now if we go to the question, the graph shows the distance asteroid 2012 DA14 travels in x seconds. So let's make x blue. We're going to make x blue. X stuff is blue. Write an equation of the line and interpret the slope. We know the equation of the line is y equals mx plus b, slope-intercept form. And interpret the slope. Another way of saying slope is rise over run. We'll come back to that when we solve it. So the asteroid came within 17,200 miles of the Earth. Miles, that's distance. So this is y-axis is red. About how long does it take the asteroid to travel that distance? How long? That is time. How long does it take? So if I ask you how long does it take to get from Etna to Houston, hopefully you'll reply with a time and not a distance. So first things first, we're going to find the slope. We're going to use this formula, y equals mx plus b. So y equals, here we have this coordinate down here of 0, 0. This is the other coordinate. And this fits the form of 0, comma, a number, which means this is our y-intercept. That means b equals 0. So we're going to put plus 0 here. The next thing we're looking for is the slope. So I'm going to use this formula to find the slope. So y2, it doesn't matter which one is y2 and which one's x2. So I'm going to label this one y2 and this one y1. So we're going to do 24 minus 0 over 5 minus 0. So our slope is 24 over 5. The book is using a decimal. I prefer fractions, but whatever floats the boat. So now we plug this in. Y equals 4.8. Sorry, the m, slope, equals 4.8. And then we have x. So we have the equation for our line. But when we look at this, does 0 do anything? It really doesn't. It doesn't change anything. So we're going to rewrite this equation without the 0. So we have the equation of line. Now we want to know how long does it take, or the x value, when the y is 17,200. So this is x stuff. This is y stuff. We have these letters. We can replace the numbers. So y is 17,000. $200 equals 4.8 x. Remember, the operation that's occurring between these two is multiplication. We want to get x by itself. How do we do that? We're going to divide both sides by 4.8. And this gives us 353.83 is equal to x. If we look up here, it says about how long. So this means to estimate. So we're going to convert this into hours because they want it in hours. So I'm going to set up the T-post. If you've taken a chemistry class before, you're going to know what this is. So remember, our unit for this was seconds. So this is in seconds. We want to go from seconds to hours. So to do that, we need to have seconds on bottom. We need to end with hours over here. So how can we get from seconds to hours? Is there a unit in between? We have minutes. We have minutes. We always put the given unit over 1. So if we have minutes to seconds, how many seconds are in a minute? There's 60 seconds in 1 minute. How many minutes are an hour? There's 60 minutes in 1 hour. So if we look, the units will cancel out and we're left with just hours. So the way you put this into your calculator is 3583 divided by 60 times 60, which equals 0.99 something hours. But we're looking for the estimate, and so that is basically 1 hour. So it takes us about it takes the rocket about an hour to travel 17,000 miles. So the last thing we're doing is interpreting the slope. So we said slope is rise over run. So if we take rise over run, and then we replace the rise and the run with our units, it is distance over time, more specifically, miles. In words, this division means per second. Remember this division. And how fast did we go? What was our slope? It's 4.8. So that means our slope is saying that the asteroid is traveling 4.8 miles per second. All right, so I'm going to take a sec, and then we're going to do example 2. Better yet, example 2 will be its own video.